And when we learned more about how to measure distances in space, we figured that it actually might not be a binary system, it might be a ternary system instead. Just the third star is not very bright. The third star is what is here in that red circle. We are not yet entirely sure if it's really a ternary system or whether the third star, which we call Proxima Centauri, is a separate star system. So when is it a separate star system? When is it a ternary system? It depends on whether they're gravitationally bound. And we just did not have enough time to observe whether they are gravitationally bound to each other or not. There's evidence for both, for being gravitationally bound or not. But this Proxima Centauri is really, apart from our Sun, the closest star to Earth. Does anyone know how far away Proxima Centauri is? It's about 4.4 light years. What does it mean, 4.4 light years? It means that light takes 4.4 years to travel from Alpha Centauri to us. Which means we never see Alpha Centauri the way it is right now. If you look at a picture of Alpha Centauri right now, that picture is 4.4 years old. That's what it means. How fast is light? Does anyone know approximately the speed of light? 300,000. What? 300,000 kilometers per second. 300,000 kilometers per second. How far is 300,000 kilometers? What's the circumference of Earth? It's about 40,000 kilometers. With 300,000 kilometers per second, you could go around Earth 7 to 8 times in 1 second. That's how fast light is. It takes light 4.4 years to reach there. So how long would it take us to travel there in a spaceship? Well, as long as we don't figure technology that allows us to travel at what we call relativistic or super relativistic speeds, it's not doable within the lifetime of normal human being to travel to other stars. We can go to other planets, they're pretty close. Yeah, like Mars, it's a hot topic these days. Has anyone seen Mission Mangal? If you haven't, please watch it. It's an amazing movie. I've seen it twice, and I want to see it a third time. And pay attention to the to the house number of the project manager. It's 42. If you're into sci-fi books, you know what the meaning of that number is. And there's a sci-fi series called Star Trek, in which they have a fictional technology which allows to go faster than the speed of light. And the interesting thing about Star Trek is they never just come up with some fantasy technology. They always try to root whatever technology they come up with, they try to root it in science. So it was still fictional, but then it somehow worked the other way around as well. Does anyone know what that is? The picture. What it depicts. Come here, please. No, but it's close. It's a good guess. It's not a wormhole, but it's related to wormholes. We figured out that something like wormholes, there are two scientists that discovered this theory that would allow wormholes. One of them is an Indian, the other was Einstein. It was Einstein and Boson, those two scientists. And I don't know, it was the third one as well. The third one was Boson. They're called Einstein, Boson, I confused it with Einstein, Boson, condensate. But this is not a wormhole, but it is still based on relativity theory. This is a so-called warp bubble. A warp bubble. Warp like warping something, a bubble like, well, a bubble. It's called a warp bubble, and the idea was to warp space. So why do we want to warp space? How did someone come up with this? Who came up with this? The person who came up with this is Mexican physicist, at that time he was a student of physics, Miguel Hujer. He watched an episode of Star Trek, saw the warp drive, and then he just asked his professor, well, how real is that? The professor said, well, it's fiction. It can't be science. Well, we don't know. Theoretically it should be possible, but no one ever did the maths. So Miguel Alcubierre sat down, did the maths, and figured out that it's not just something that allows for being faster than the speed of light without breaking relativity theory, but the formulas say you can actually make it happen. And this is a depiction of what such a warp drive would do. A warp drive would bend space. It would contract space before the spaceship, and it would expand space behind the spaceship, and therefore the spaceship itself, within its local frame of reference, would not move faster than the speed of light, but space itself, that bubble, would move through space faster than the speed of light. And the general theory of relativity allows for that. But there's of course a lot of technical problems to do that. This is like, to tell you how far we are from the realization, it is like me 10,000 years ago taking a flintstone, making a fire, and while doing so dreaming of a combustion engine. That's how far away we are from that technology. But we can think it up with our mathematical formulas. And there's just a problem with that. The problem, in order to bend space like that, the formulas tell us that in order to do so, you need negative energy. Now, I'm not Sadhguru and telling you now in order to create a warp drive, let's all have bad thoughts. That's not what's meant with negative energy. And negative energy is an artifact of formulas that simply have two solutions. A positive solution with positive energy and a negative solution with negative energy. Now, can that exist? Well, maybe not, is what you might think. But we already have proof that finding a second solution to the formula can become real and even have practical applications. Have you heard of antimatter? Did you know that you can go to a sophisticated hospital in Hujer and find a medical application of antimatter? Did you know that? How was antimatter found? When Paul Dirac, quantum physicist, came up with equations about quantum mechanics and about the particle physics, which make up the standard model of physics, particle physics, his formulas his equations had two solutions. One solution would give us the well-known particles, like proton, the neutron, the electron, and the other solution would give us mirror particles, which would behave like the same particles that we know, just with the opposite charge, which means the particle that is as light as the electron, but instead of having negative charge, it would have positive charge. And a particle that's like a proton, but instead of having positive charge, it would have negative charge. And for several months, people thought that this was just an artifact of the maths, and it wouldn't be real, until in a lab somebody observed a particle that behaved exactly like an electron, except for the charge. It moved in the opposite direction in the magnetic field. So this particle was called the positron, and if you go to a hospital, I hope you never have to do this because it is only used for a very specific kind of diseases where you need to scan the inner parts of the body. But in some hospitals now you have a positron emission scanner as a tool for medical analysis. So antimatter is even in practical use in hospitals today. So this is an example that just because something there is there in maths doesn't mean it's just maths, but usually the maths in physics reflects reality, and if we find something in maths, then we can go looking for it in the real world and maybe we're going to find it as well. So we found antimatter, and we now even have to put it to practical use, so we might as well find negative energy. Does anyone know what that depicts?
Sun.
Exactly, that's a black hole. And according to Stephen Hawking, this is where you find negative energy. We now know that the vacuum of space is actually not really empty. First, and that's again an example where formulas actually showed that something is going to be real. Richard Feynman made Feynman diagrams which would explain physical reactions much better and much easier to understand by inserting virtual particle-antiparticle pairs into the formula. And that would make these formulas much easier to understand. And then people figured out, but if that makes the formulas easier to understand, then we can actually put these formulas in other places as well, including the empty vacuum of space, and it would mean that these virtual particle pairs with these formulas are really good, and we should find them in empty space. And these virtual particle-antiparticle pairs, they just spring into existence and immediately dissolve themselves. But they should still cause a measurable gas pressure. This gas pressure is called the Casimir effect, and it was measured. So we know that space, that empty space is not empty. And we're not talking of the occasional hydrogen atom that you find in empty space, but we're really talking of quantum fluctuation in the zero-point field of empty space. It really exists. We could measure its effect, the Casimir effect. And then Stephen Hawking theorized that if that happens at the event horizon of a black hole, then it could happen that one of these two particles actually is on one side of the event horizon, the other is on the other side of the event horizon, and then they would be torn apart. So they would not dissolve. Instead, the particle that falls in the black hole would make the black hole smaller by exactly one particle, and the other particle would be emitted into space. And that's called Hawking radiation. So now, one of the things that astrophysicists look out for as they look at black holes, they try to observe this Hawking radiation. But what is the energy of the particle that falls into the black hole? That is negative energy. Okay, so can you go inside a black hole, get the negative energy, and go out again? That is where the chicken and the egg meet. So when you have a warp drive that does not have fuel, you have to get inside a black hole, fuel it with negative energy, then you have a warp drive. And with a warp drive, because you can go faster than the speed of light, you can now go out of the black hole as well. It doesn't work with small black holes, but it works with big black holes where the distance between the event horizon and the singularity that is destructive is very big, where you can survive for weeks and months until you're destroyed. But if you harvest negative energy from a black hole, the black hole would stop emitting Hawking radiation. And here comes my hypothesis. I'm not serious about this hypothesis, it's a fun hypothesis. Maybe the fact that we do not observe Hawking radiation at the black hole Sagittarius A star in the center of our galaxy is evidence for an advanced civilization that is harvesting negative energy in that black hole to fuel their warp drives. But we're not here to talk about space, right? We're here to talk about extreme programming. So let's do that. All of you have heard of extreme programming before? Hands up. Only one has heard of extreme programming before. But why? Everybody else, why are you here? How old is extreme programming? Yeah, about 20 years. Yeah. I haven't seen anyone of the extreme community like Ron Jeffries or Ken Beck or so tweeting something like 20 years of extreme programming and let's celebrate it or so. And I'm not sure why. There could be different reasons why it's not celebrated. One reason why it's not celebrated may be because there is not a single day that you can pick in the calendar and say, this is the day where extreme programming started. I can imagine it's very difficult to try to pick such a date. Because extreme programming is not something that happened on a day, but it's something that evolved over time. And if you look at what extreme programming is, you will know after this talk, then you will also understand why. Because it's not really something new, it's just a collection of good practices. But there's also something else why maybe it's not celebrated. And for that, let's look at this. Who knows that? A lot of people seem to know that, at least half of you. That's good. Because I think it's important to know this is the Manifesto of Agile Software Development. Some people also call it the Agile Manifesto, which I personally find hilarious because I never have seen this dancing on my desk. The manifesto itself is not agile. It's a manifesto for agile software development. Someone who's good at parkour. Does anyone know what parkour is? It's a sports discipline where you jump from house to house. These people are truly agile. Yeah. That's what agility means. But the manifesto itself is not agile, but it's about a process or aspect of a process to make it agile. Who invited for that meeting where this manifesto was created? It was a very famous person. I'm sure that a few of you know that person. That person is known as Uncle Moore. What's the full name of that person? Robert C. Martin, exactly. Robert C. Martin invited to a meeting in the Rocky Mountains, as in the background you can see these people standing in front of a board. This is Martin Fowler. That I think is Robert C. Martin at that time. And the other people are some of the other people who just were at that meeting as well. And he called it the lightweight process meeting. It was called the lightweight process meeting because at that time a lot of people in the industry were part of a big counter movement to, then obviously there has to be something called a heavyweight process. Sometimes it's depicted as a movement against the waterfall, but actually against the waterfall is not entirely true. It doesn't give the full picture. It's against heavyweight processes. It's a lightweight process meeting. And in the lightweight process meeting, there was a number of people that shared, or maybe they just wanted to check if they share a common set of values and principles. Most of them were developers. Robert C. Martin is a developer. Kent Beck is a developer. Martin Fowler is a developer. Most of these people at that meeting were developers. And most of them represented already a specific process. The majority of the people represented, not the majority, but the biggest group for a single process was extreme programming. Robert C. Martin, Ward Cunningham, Ron Jeffries, Ian Beck represented extreme programming directly. And if you read Martin Fowler's blog, you will see the process that he favors also is extreme programming. There were two people representing Scrum. That was Ken Schwaber and Jeff Sutherland. And the rest of the people represented other processes like Crystal. There was Alistair Coburn, and then there was feature-driven development, and then there were Dave Thomas and Andrew Hunt representing what they call pragmatic programming, which is what they call in their book, Pragmatic Programmer. And so they came up with this, the Manifesto for Agile Software Development. And who of you uses Jira or something like Jira? Hands up. Is it a tool? Quite interesting. Because this manifesto says, through this work, we have come to value individuals and interactions over processes and tools. That is, while there is value in the items on the right, we value the items on the left more. So the idea is every time you're picking on a tool or on a process, you should actually remind yourself that the tools and the processes should be the slaves of us and not the other way around. Tools and processes have to serve humans and not humans serve the tools and the processes. And that's one of the things what this means. Now there's more to it. For example, a visual workspace, but we're going to come to that. So this was 2000 published, and at that time extreme programming was the predominant method or process that people were talking about when they were talking about Agile or agility. Before this meeting, they didn't even know what they're going to call it. It was not called the meeting for creating the Agile Manifesto or the Manifesto for Agile Software Development. That's not what the meeting was called. It was called the lightweight process meeting. And then in that meeting, somebody said Agile, and then they went with that. Historically, they would have been good, but then things went slightly differently. So, one of the outcomes of this meeting was this manifesto. One of the other outcomes of this meeting was the formation of the Agile Alliance. And for the first few years, the Agile Alliance didn't really do much, other than just exist, but it didn't do much. And in parallel to that, Robert C. Martin had the Extreme Programming Conference, and Ken Schwaber and Jeff Sutherland had the Scrum Conference. And it was always the same people attending both conferences. It was the same speakers speaking at both conferences, and it was the same topics on both conferences. So they met in the Agile Alliance and said, so this is a bit redundant. What are we going to do about that? Back and forth. The decision then was that Ken Schwaber and Jeff Sutherland by Robert C. Martin's conference. The Extreme Programming Conference was closed down. The Scrum Conference lived on. A year later, they had the idea to come up with certifications for Scrum Masters. And that's where, in my opinion, we went down the drain. Because, India might be a bit different, but still I think it's also an applicable rhetoric question in India. Are software developers interested in certifications? Not so much. Even in India, where so much is about certification, software developers are not that much interested in certification. Because for most of our technology, a certification industry couldn't keep up possibly with how fast technology moves. They're not interested in certification. But there's another group of people who is interested in certifications. Project managers. They're interested in certifications. Because they need all these points for keeping their titles. For their Prince and PMP, they need their titles and they need their points. So they're interested in certifications and classes. And that totally changed the game. Who of you has attended a Scrum class and learned about Scrum? Let's ask you, okay? What did the Scrum class tell you about how to write code? Nothing. Exactly. Nothing. Can anyone show me a serious business of today which is not about software development? Doesn't exist. Every business of today is about software development. You want to run a hotel? Can you do it without software? No. Want to run a big hotel? You can't do it even less without software. If you want to run a hotel that isn't even a hotel itself, like Airbnb, you only need software. You don't need anything else. Want to run a cab company that doesn't even own cabs? It's all about software. Look at Uber. Everything we do is about software, and Scrum doesn't lose a single word about how to write code. I think that's a catastrophe. And that's why I continue to promote extreme programming, because extreme programming gives you everything Scrum does, but also tells you how to write code. Which means in comparison, I find Scrum very professionally unhelpful. Which is the perfect thing for consulting business, by the way. Because what does a consultant do? Consultant either, I'm now thinking on my own because I'm a consultant. So, but what do consultants often do? We just tell you what you already know. But as soon as it's an outsider who management gave money, management now will also listen. That's one honest truth about consulting business. The other honest truth about consulting business is that we try to tell you as little as possible. The more we tell you, the more we could be held responsible and accountable. You know what the first answer of a consultant usually is? It depends. But it also shows that it's difficult. Because it depends is also an honest answer. Because there is no absolute truth, except for that there are no absolute truths. Which also means that whatever I tell you, take it with a grain of salt. There's no process that fits everyone. And whatever people tell you, you always have to change it to your situation, your requirements, your people, your social structure, your clients, your project, your product, and so on. This void of technical excellence, despite technical excellence being one of the 12 principles behind the Agile Manifesto, concerned people like Robert C. Martin. So, 10 years later, they came up with this. Who knows that? Now, a few people know that, it's great. This is the Manifesto for Software Craftsmanship. And it says not only working software, but well-crafted software, not only responding to change, but still adding value, not only individuals and interactions, but a community of professionals, which is exactly why we are here. We are forming Meetup groups, and we go to conferences, and we arrange training classes and so on to create communities of professionals, and not only customer collaboration, but also productive partnerships. This is basically a counter movement, not posed against the Manifesto of Agile Software Development, but next to it, to actually close gaps. I don't really think that this is a gap in the Manifesto for Agile Software Development, but it's definitely a gap in Scrum. And I mean, this whole Agile stuff has gone really totally nuts. If you look at it, like people now write Agile with capital A as a proper noun, not even just a normal noun, a proper noun. Which other proper noun do you write with capital letter? God. Yeah, that's the level to which they elevate this. And also, now there are agile coaches that pretend that you can be an agile coach without knowing anything about software development. So in order to justify that, they have also redefined coaching. Yeah, so coaching now has become like a psychological placebo, where you just ask like, do you feel good with what you're doing? Or something like that. So that's how they redefine coaching. It's completely void of matter. They said, oh, but if you want to talk about the real stuff, then you have to go to a consultant, not a coach. Yeah. So that's one thing they try to sell people. And I think it's detrimental. I've recently seen a similar movement happening with testing. So people like me, since decades, we're trying to tell people proper testing is automated, proper testing is accessible, proper testing is fast, proper testing is something every team member can do on their desk, on their machine, anytime they want, any way they want. And it has of course to be reproducible, so it has to be automated. Then some testers came and said, no, testing is also about exploration, finding the direction of the product, and so on. And what you call actually is check. I call this bullshit. You've just relabeled requirements engineering as testing as an excuse for the fact that you don't want to learn programming, to automate your stuff. That's what you've actually done. Okay, so let's go into extreme programming. It was actually created in a big corporation. That's something very interesting to see. It doesn't mean it doesn't work in startups, but why I like telling this is actually some people think extreme programming is only for startups. It can't possibly work in a large corporation. It can. It actually has been created in the environment of a large corporation. It has been created at Daimler Chrysler. Actually, at that time, only Chrysler. The project at which the people were working was stopped when Daimler purchased Chrysler, which they shouldn't have done for two reasons. It was a bad business deal, and it broke the evolution of extreme programming. Because they stopped the project, and when they've seen how the people worked in that project, they had even issued a message across whole Daimler Chrysler that every software development team is forbidden to ever do extreme programming. Which I think is a bit shameful, because you see what proper software crafts people think of extreme programming. They had to retract from that. A few days later, they said, well, we didn't mean it like that. We didn't understand it at that time. It's not what they said, but it's what they meant. So let's talk about the two values of software. Because what I'm talking about also has a lot to do with refactoring. What Martin Fowler wrote in his book Refactoring. In his book Refactoring, he wrote, the subtitle is Improving the Design of Existing Code, and he wrote that his book is written on a rather fragile premise, which is that good code matters. And I do not think that that is a fragile premise. And I want to explain to you why I think it's not fragile. It's a very important premise. The model of two values of software is created by Robert C. Martin. It is not part of extreme programming in its original definition, but it's part of how I explain extreme programming. And I start with the secondary value of software, because that is what most people think of first when we talk about value of software. The secondary value of software is its behavior, that it does what the current users currently need without any bugs, crashes, or delays. That obviously is important. If it weren't important, it wouldn't be on the slide. That is the secondary value of software. But there's a problem with that. Because there's one more absolute law. The only constant in the universe is change. And our software is no exception, which is users change, their needs change, markets change. Software has to change all the time. Software that doesn't change goes out of business. Software that doesn't change is going to be replaced by something else. So it does change. And that leads us to the primary value of software. The primary value of software is its structure. A structure that is soft, a structure that can accommodate exactly that change that the market needs. And the reason why that is the primary value of software is because of a dependency. The secondary value of software depends on the primary value of software. Imagine a project that does exactly what the users need, but you can't make a single change. The project is going to go out of the market after some time. Imagine a software that doesn't do what the users need at all, but you can easily change it. That is going to be successful. Actually, there's a process name for it. We call it Greenfield project. At the first day, the Greenfield project doesn't do at all what any of the users need. Every fresh project starts exactly like that, but it's easy to change. So it's because of that dependency that the secondary value of software depends on the primary value of software, while the structure and the ease of change is the primary value of software. That leads us to the mantra of extreme programming, which is embrace change. Embrace change is the mantra of extreme programming. Does anyone remember the mantra of Scrum? Of Scrum, the mantra is inspect and adapt. It's the mantra of Scrum, which I think also is a good mantra. What does inspect and adapt mean? It's actually the two sides of feedback. Inspect is the active process of gathering information for feedback, and adapt means, after evaluation of that feedback, improve your process and improve your way of working. That's what it means, inspect and adapt. This is a picture of the feedback loops of extreme programming. When you compare that with Scrum, one of the things that you should already notice is that some things are in common. And that's not a coincidence. Neither Scrum nor extreme programming just invented whatever they have out of thin air. Whatever elements they have is based on years and decades of industry experience. Also note that this picture is 20 years old and should be looked at from that perspective, 20 years old. Because, well, this is the unmodified original picture, except for the color and the arrows. But the concept of the picture is unmodified, the original picture, and I'll talk about where I today no longer agree with that picture. But let's look at what we have. It's centered around code. That's also why it's called extreme programming, because the stuff that we sell, it's not documentation, it's not tests, it's not requirements. The stuff we sell is working software. Everything else we do only serves to enable and improve the way how we create working software. Nothing else is what we sell. Next element here is pair programming. We're going to talk about that in detail in a moment. But pair programming is the primary way of producing code in extreme programming. Every line of code, no matter whether it's test code or automation code or production code, should be written by a pair of people. We're going to talk about the details of that in a moment. Then with unit test as an explicit process element, I would actually have written test-driven development, but this is the original labels. Then with paired negotiation, that means every few hours, the pairs that comprise pair programming change. Yeah.
What is seconds and pair programming? What is seconds?
Yeah. So this means that because you're doing pair programming, you have every few seconds you have a feedback over your code. I mean, pair programming doesn't work like you get the left half, I get the right half of the keyboard. That's obviously not the way how it works. It works differently. Like only one person on the keyboard and the other person is doing other things, like what, looking at the screen, thinking of the impact and stuff like that. But that means because we're doing pair programming, I get a code review feedback while the code is created. By the way, who of you is using a sprint board, like a Jira board or something like that, for your iterations or your sprints, or a Kanban board or something like that? You're using almost everyone, great. So how many columns do you have on your board? What are the labels of these columns?
In progress, review.
To do, in progress, review, done. It's one column too many. You should only have 3 columns on your iteration board. To do, in progress, done. Every other column that you have is a symptom of an underlying process defect. Every additional column that you have represents an unnatural gate. What do I mean by unnatural gate? A natural gate is a gate that you must have in your process, you can't do without. Moving work from to do to in progress is a natural gate. And moving work from in progress to done is a natural gate. Natural gates are defined by the laws of thermodynamics. But other gates, like in review or in test, which are the 2 most popular other columns to have on the board, I call them unnatural gates because they are not a result of that you developing software, they are a result of how you design the workflow through your team. And I don't think that they are good because they mean that your stories have to wait for something. They're waiting for being worked on is natural, but waiting for being worked on again is not necessary. And pair programming solves and addresses the review column.
Don't you think that has come from SDLC mindset and expertise and other things? Because if you see Kanban,
Yeah.
Kanban has only 3 columns.
Yes?
To do, doing, and done.
Yes.
Now this 4th one has been added specifically in Scrum, which is a part of a actual SDLC framework, which is basically says that okay, you do the code, somebody reviews it, then goes for testing, and then goes for whatever.
Yeah. And it's teams who do that. So Scrum actually doesn't tell you about anything about the columns. Scrum is silent about that. But a lot of teams do that because they do not properly understand Agile or agility are actually properly phrased. And they try to map things from their previous SDLC, waterfall, V model, double V model, V model XT, Spice, CMMI, whatever they did in the past. They try to map these things to the new stuff. And of course, it's only natural to attempt that mapping. What fails there is the Scrum Masters with experience. They've just gone to the Scrum training for 2 days, passed the test. Now I'm a Scrum Master. Now I know everything. Please listen to me. You have to make a board. And then they don't realize that actually, just by having a board and having ceremonies, you do not become agile. And Kanban, mentioning that it is awesome, I love Kanban. Yeah. Another thing that often goes wrong is, should we go for Kanban, or should we go for Scrum, or should we go for extreme programming? This is not a mutual exclusive set of answers. It's like, do you want to have rice or curry? No, obviously both. So it's these things are not mutually exclusive. The worst type of answer I got to a question like this was the following. I asked the company, have you considered behavior-driven development and Cucumber for improving the way how you test? And they said, no, because we're using Selenium. That really shows a complete lack of understanding of what these things are, and also what testing are, on what layers of testing and certain things operate. These columns are a legacy, and I want to get rid of this legacy, because each of these additional columns is an opportunity for the story to sit idle and wait, and therefore increase cycle time. And also, these columns often mean bottlenecks. And we want to set up processes that do not have bottlenecks. We're going to talk about bottlenecks a lot, like with pair programming. No? But I don't like measuring velocity in projects. In the beginning, 20 years ago, I liked it. I liked it until I understood a few things about it. The first moment I started to dislike velocity was when an extremely motivated manager tried to optimize the team's velocity. And that impacted the self-organization mechanisms of the team. Now, the team understood that velocity isn't everything, but as soon as velocity was used as a KPI, you get what you measure. And velocity is about output and not about outcome. Velocity is about how busy you are and not about how much value you deliver. These are two different things. You can be very busy and produce no value. Look at a typical office, and you can see that very well at work. So, what I'm more interested in is cycle time. Like, if you have something that you want to get done by the team, how long does it take until you have the result in your hands? That's much more interesting than velocity. Those columns, they can work very well with velocity, but cycle time will expose those columns. Back to the cycles. So seconds means you get feedback by pair programming for seconds. Yeah? You have a second pair of eyes looking at the screen, telling you this is good, this is not good, let's do it differently. Then every few minutes, nowadays even also every few seconds, you run the unit tests. Yeah? There's different definitions of unit tests. Some people think that units are classes, others argue no, they are methods. I think both are wrong. A unit is a compartmentalization of behavior. And whatever that is, a method or a class or multiple classes together, that's just a physical representation of unit. But from the perspective of testing, unit is just a compartmentalization of behavior. And another aspect of unit testing is one of the most important things about unit tests is that they run fast. It's something I would not only like to see with unit tests, I would like to see that with all tests. Because how often are you going to run your unit tests if they take 3 seconds to run? You're going to run them all the time. Yeah? You get a phone call, you don't even think, hey, did I run the unit test? You just click the button to see the result. 3 seconds, you can wait there. How often are you going to run the unit tests if they take 1 hour to run? Yeah. Once a day, twice a day, maybe. And then what happens is you look at your calendar and then you say, okay, I'm gonna go for lunch, I'm gonna run the unit test then. And then we have department meetings, so there also I'm gonna run the unit test. So now the driver, the time driver of the software development process suddenly has been externalized. It's no longer your engineering that drives your feedback cycle, but it's external things like your meetings and your lunch driving your feedback cycle. That shouldn't be the case. Similar with acceptance tests. Same thing, doesn't matter which type of test we're talking about. We're talking about functional feedback. Feedback about functional correctness. We should get that feedback often, we should get that feedback early. The pair negotiation, that should happen every few hours, changing the pairs. Then once a day, stand-up meeting. And by the way, all these things are optional. Yeah? It doesn't mean that you must do all of them. If you do one of these, then you're not doing a sprint program. That's not the case. You have to tailor everything you do onto your team, onto your project. And there's a story of the Scrum Master who came to that team. The team was sitting in an office that was about a quarter of this space, all around the desk, stretched like this. And then the Scrum Master wanted them to have a daily stand-up meeting. As for what? So that you know what each other is doing. And we were talking with each other all the time. We know what we are doing. What should we do with a DSM? These ceremonies shouldn't be done for a lip service, they should be done for a purpose. And if the team found an even better way of achieving the same purpose, don't force a ceremony on the team that doesn't fit the team. Then acceptance test. And this is how it was written originally. Mind you, this picture was written 20 years ago. With 90s computing on the mind. This paper was written by, and this picture was designed by people that worked on Pentium machines or 486 machines. These machines weren't very fast. They did not even remotely have the computing power of our cell phones of today. So I would actually relabel this to acceptance test specification. So every few days, a new set of acceptance test specifications flows into the team as the new work that has to be completed by the team. The actual execution of acceptance tests is something that should happen as part of the normal development flow alongside the unit tests. Then iteration plan, weeks, that's like a sprint. It's something I no longer want to do with every team. I think a continuous flow, like suggested by Kanban, makes a lot of sense for a lot of teams. You will still have occasional planning meetings, you will still have occasional review meetings with the customer. You will still definitely should have occasional, or just occasional, regular retrospective meetings. By the way, out of Scrum, I think retrospectives are the single most important ceremony. You can remove every other ceremony and Scrum might still work. Scrum might also break if you remove any of the other ceremonies, but the retrospective will tell you. Because if you break Scrum, you meet in the retrospective meeting, and stuff is not working. Why is it not working? We had a sprint, but we didn't know what to do. We had no stories planned. Or whatever you break, you'll find out in the retrospective. Remove the retrospective, and you have no feedback about the process. But there again, the retrospective doesn't have to be a meeting. The retrospective has to be a feedback mechanism. The purpose why Scrum says you should have a retrospective every end of a sprint is to have a rhythm and also to make sure it happens. Same thing is when I look at Scrum in the wild, the retrospective is the first meeting the teams drop when under pressure. It should be the last meeting to drop. If you have a retrospective, it means you're now not only under pressure, but you also have stopped trying to understand why you're under pressure. And you stop looking into it. And then release plan, that's also something I would no longer do. Maybe for some projects, but it depends a lot on the market. I actually like to work in a way where every green build is given to the user. This is how I like to work. Every green build is given to the user. For that, of course, the build and the pipeline have to be fast. So that's an overview of the feedback loops. Let's look into the things in detail. Pair programming. One of the typical management questions about pair programming is, but what about productivity? As soon as you tell a manager that you're doing pair programming, they're immediately worried that the team's productivity would be cut in half. One of the important things to understand is that most of the development work is not typing, but thinking. And it's important to understand that thinking works significantly better if humans are not alone and isolated. There's not a single great idea in human history that has been created by anyone completely isolated and void of communication. And if you show me something, then we can still work out that this is probably the exception and not the rule. Like Einstein. Think of the same person. Lock that person in a room without communication with any other scientist, probably wouldn't have come up with anything. Communication is crucial. And with pair programming, we ensure that every piece of code written happens with communication about the code in place all the time. So brainstorming and verifying ideas, but it has a lot of other effects as well. Has anyone heard the term bus factor or truck factor? Can you quickly explain it?
The bus factor is like, at least from my point of view, it creates dependencies on one person having a knowledge or expertise in the particular area.
Yeah, exactly. So, in other words, it's the risk that a project has if a person becomes unavailable because they're run over by a bus or something else happens. That's why it's called bus factor. And it's because of dependencies on single people. That can be domain knowledge, that can be process knowledge. And with pair programming, we're trying to break both. We're trying to break process knowledge, and we're trying to break domain knowledge by having every piece of code being written by rotating pairs, so that every person in the team knows all steps of the process, and that every person in the team knows all domains. So in software architecture terms, like domains would be the verticals, and the process parts would be the horizontals, like front-end, back-end, database. But then when we look at the third dimension of time in the process, there's things like requirements analysis, test specification, test implementation, design, production code, test execution, deployment, automation, and so on. There's so many things that we have to know, and there's something very interesting. I'm going to keep that for the corresponding slide about DevOps. Again, a role going bad, and it's crazy. I'll tell you once we're at that slide. So we want to make sure that the bus factor is low. But also, what do you think is the effect of pair programming on onboarding? It's obviously brilliant. With pair programming, you don't need any other onboarding program. Yeah? Team is doing pair programming, just put a new team member in the team. They can learn everything automatically by doing pair programming. In order for a cross-functional team to work, like today I work on front-end, tomorrow I work on the database, and the day after tomorrow I'm going to work on back-end. Which makes a lot of sense if we think of agile work. User stories. What are user stories? They're vertical slices of work. Add a field to a form in HTML is not a user story, it's a class. saying, as a customer, I want to be able to store my middle name so that I feel more comfortable with the application, that's a user story. But in order to achieve that, it has to be in the front end, back end, and the database. That means the natural way of slicing work in Agile project must be vertical. Also because we want to make sure that whenever we finish work, we deliver actual value. And our front end, without a back end, without a database that have the same capability, there is no value. The value is only achieved if it's in all layers at the same time. And that's one of the key things about the Agile process. Being able to change direction any time without having creating waste. If I say, let's say the project has 9 months. And the times are of course completely fictitious. But let's say we have 3 months of back-end work, 3 months of front-end work, and 3 months of database work. And then we say, okay, for the first 3 months we're going to finish off the back-end. And then the project is stopped. What's the value of the project? 0. And if we have 9 months of user stories, then we say we implement the most important user stories first, and then we work for 3 months. And in these 3 months, we have done all the things, but only for a third of the user stories. How much value do we have? We have a third of the value. So, user stories have to be vertical. But in order to be able to work on vertical user stories, the team and the individuals in the team have to be cross-functional. How can we achieve that? Pair programming, but it also means we need a common coding standard. How can you enforce and develop and evolve a common coding standard? Again, pair programming. You should not be able to look at a piece of code and say, okay, this code was, that looks like it was pristine. That code, that clearly was such it. That's not how your code should look like. You should not be able, by looking at the code, which individual was writing it. When you look at the code, what you should see, I guess this code was written by a competent team. That's how your code should look like. So, there's a bit about pair programming. I'm not going to go into details too much. Just if you want to know more about pair programming, there's a professor at the North Carolina State University. Her name is Lori Williams, and she's basically our industry expert for pair programming. She has done studies with large companies and universities and small companies, and the results are clear. In the worst case, pair programming did not slow down the team. That was the worst case. In every good case, the efficiency of the team has increased by at least 15%. Unit tests?
Christian,
Yeah.
maybe I have little bit experience. One question, David Sarbogan, on the pair programming.
Yeah.
As an individual, probably I have a choice or a liking what I would like to work. Front end, back end, etc. 1 point. Second question is, as an individual, I would like to think alone a little bit. Not always pair. What's your stand on these 2 points?
On the first one, I'm a bit sad about that type of specialization, but it's a reality that it's there. And if you're a total front-end lover, you could possibly still work in an XP team through the pair rotation. But I don't know how true the following statement is. All the people that I know who I think they are really extremely good at programming, they do not have such preferences. And so this preference front-end versus back-end. A similar preference could be one programming language over another programming language. I mean, sometimes, of course, there are practical arguments about programming languages. You would not want to develop a normal Android front-end application in C. There's just technical aspects why we can have a very solid technical argument against C in that case. Whereas if we were to develop an Android game that should be performing extremely well, then we would have an argument that would be very much in favor of C. There can be certain technical aspects, but for the vast majority of developers, whether we're going to write that piece of code in Java or JavaScript or Python or C# will not matter. Then I had an episode of several months Perl programming after and before Java. So I was a Java developer, or developed in Java, and then I developed Perl, and then I went back to Java. And that few months Perl programming has tremendously changed the way how I wrote Java code. And I think we are quite often quite immature about technology. Technologies come and go. Java, some people already call Java blue collar. I mean, when it comes to business dominance, it's definitely clear. When it comes to legacy, Java also, you can see how it's growing of age. And then, if you're leaning back in your chair and say, well, I'm a C# developer, they are the same language. And anyone who tells you so is a lawyer or the slave of a lawyer. So C# is growing the same age. So principles and practices, these are the things that stay. Do you know how old test-driven development is? The first documented account of test-driven development is from the Mercury project. What is the Mercury project? Not Mercurial. Mercury project. NASA putting the first American into space before the Apollo program. That's the first documented account of test-driven development. That engineering team was writing the tests in the first half of the day, was writing the production code to make the tests pass the second half of the day, and ran the tests overnight. I don't blame them for using the same TDD mechanisms of the day, because the machines were simply not that fast. They were still carrying punch cards around. But for what their machines could do, they had really the best process. So that stays. When did functional programming become popular? It's just recently, isn't it? Yeah, like now Java has lambdas, and C# has lambdas, and even C++ has lambdas. They're all of them changed to have lambdas. Lambdas are obviously coming from functional programming. How old is functional programming? Of the three true paradigms, structured programming, object-oriented programming, functional programming is the oldest. 1957, John McCarthy, lambda calculus. This is the oldest. Principles and practices stay. Technologies come and go. Yeah, like get a time machine into the 90s, talk to a typical developer, and listen how much they despise the mainframe. And today we're back on the mainframe. We just call it cloud, and we replaced the VT100 terminal with a web browser. But technology-wise, otherwise we're back on the mainframe. We're back on centralized computing. Full circle from the 70s to the 2010s. Full circle. So, my advice to a developer who wants to specialize in a horizontal would be, think of how compatible that is with an agile way of working, and think of what type of company you want to be with. Take that into consideration. If it doesn't mean that they have to change their mind. There's a lot of companies that do not want to work agile. There's a lot of companies that do not want to work agile, but for the clients, put themselves an agile sticker on their badge. I know of a company that considered maybe hiring me as a consultant for their vendor, because their vendor has applied for the tender saying they're going to be agile, and then they had a couple of design sprints, then a couple of implementation sprints, and then a couple of test sprints. which is obviously not agile. They've just relabeled their waterfall. So I think that's something you have to take into account. And regarding thinking, nobody keeps you from thinking alone. So it's called pair programming. I think it would be interesting to also call it pair thinking, but I wouldn't go that far. It's okay to also think alone. But I don't know how you feel, or where do you get your best programming ideas? When you're working on a programming challenge, when you have a challenging problem to solve, when do you get your best ideas? When do you get your best ideas?
Morning.
Okay?
In the morning.
In the morning. Yeah. Same for me. My best programming ideas I get in the morning while I'm standing in the shower. That's where I have my best ideas. And obviously, I wasn't doing pair showering with another developer. Yeah, I was alone in the shower. Probably more detail than you wanted to know. But
Cross-functional. Now, Agile also has that, cross-functional team, which means that every member of the team should be able to do multiple things at a time. Multiple things in the sense like coding or testing and those. However, in the real world, I work for a banking software. Now, the banking softwares are not yet being, fully.
yes, I have bank-sized clients as well.
Right, so they are like either mainframes or ICAs or something like that. Now, those systems cannot be, or rather that programming languages or the architecture cannot be learned very quickly. Now, if somebody is put on with some problem, okay, learn COBOL in 2 days, who is actually a Java programmer or a Python programmer, he's just not going to understand what's going on with the actual mainframe architecture. So how do you basically take care of in XP also or in Agile? How do you take care of those cross-functional?
First, I think the way you explain cross-functional, it's a way that I also like to see it. But first, it means something else. First, cross-functional team means that all activities which are required for a project's success should be on the team. And then Agile says the team is then just self-organized. I personally just like to go one step further and say I not only want a cross-functional team, I also want the people on the team are cross-functional. It doesn't mean that they have to be equally good at everything. I do not expect every developer on my team to know everything about multi-phase SQL transactions. Not required. But they should be able to do basic stuff like a regular insert, a regular select, a regular update. Maybe they should still know what an upsert is, and they should know, in case it's more complicated than that they should talk to an expert in the team, which is where pair programming comes in the picture as well. It doesn't mean we have to be experts in everything. As a backend developer, I don't need to be able to write a fancy front-end design and think of all aspects of user experience. But if there's a task where there's already first name and last name in the form and I have to add middle name, I should be able to do that. Just to explain what I mean by cross-functional. We can't be experts in everything. That's also not required by cross-functional. But I think 80% of the work that we do in a software development project requires only 20% of the technical expertise that you could possibly have in that particular field. Like if you look at database, how often do you really need to know everything about transactions and the different isolation levels of transactions when you're dealing with when you're implementing your DAO? For most of the time, you don't need that knowledge. So it's okay to be only a, we said half-assed database developer if you're a back-end developer. For those special situations, you might still have an expert on the team. An expert might be a database expert, but then the database expert might not know everything about Spring. But the database expert for a normal REST endpoint, as long as they can write a normal REST endpoint, for which you need to know less than 20% of Spring, yeah, that's still fine. Right? Wherever the gaps are, pair programming comes into picture. For technology like COBOL, I haven't learned COBOL myself, so I can't judge how long it takes to learn a language. But if I would have to take a C# developer into a Java project, let's not take C#, it's too simple. C# Java. Let's take a Python developer. And I have to take them into a Java project. I think they should be able to, with pair programming, to be somewhat productive after like 3 days or so. I don't expect them to know anything about Java after 3 days. But who here is a Java developer? What does it mean if I open the curly brace after enum and directly put a semicolon? You can abstract. Yeah, that's why I could make it enum. But what does it mean if I directly put the semicolon? Yeah, not everyone knows its syntax. There's Java stuff that Java developers that have been developing for 10 years do not know about Java. And that's okay. Because as a developer, your job is not to know everything about the language. Your job is to know enough about the language to be reasonably productive and produce maintainable code. It's something else than knowing everything about the language. And I think that a language that requires you to know a lot before you can become productive is a bad language and should be replaced. One of the strengths of good language is that it can make you productive without knowing everything or a lot about the language. You should be able to focus on your business problem. When it comes to mainframe development, I think that Agile and mainframe are compatible. But you might have to change a lot about the environment. Like, who has access, how is access, how many environments are there, how do you simulate data, how do you have remote access, and so on. Basically, the PC world has made mainframe access unnecessarily complicated. But I think the bigger problem with banks usually is acceptance testing in general. What I observed, I've worked with a team that could release only once a year because the user acceptance test would take 9 months. That's of course also not the regular example of a banking application, it's also an extreme example, but that shows how much work is there to do. But then the banks have realized that they want to change. It makes them now all these fintech startups come up with fast processes and threaten banks in certain markets. So banks have to adapt to a faster culture of change in software development as well. I hope that addresses at least partially your question. Yet another thing about
follow-up question on this thing. I experience most of the time like Scrum Master use this cross-functional team or cross-functional capability like as a developer being testing when the time crunch time comes, like there is a less time. So now, is it like I personally feel that developer doesn't have most of the testing skills that would not be like seen as a cross-functional thing. Like we don't ask testing team to say produce a code because that's a skill. I'm certified in the development, I'm certified in testing. So how do you see that?
So I do not take any tester serious that does not write code. That might sound very cruel, but I think without people like me uttering it that bluntly, the situation is not going to change. Manual testing is an abomination. You can explore a product manually, but please don't call the testing that's requirements engineering. We've done it ever since, and if you now do that as a tester, you're just entering the domain of the requirements engineering because you're too lazy to write actual code to automate your verification. Testing means verifying a product. That's what it means first. And exploration, yeah, do that. Have the requirements engineer fine, but then don't label the testing when it's not testing. It's requirements engineering. If you're testing manually, you can't develop and deliver software fast. Because what does fast software delivery mean? It means I'm making a change, I'm making it push, and I expect the app to be in the cloud or in the app store after minutes. That's what I expect. But with the app store, of course, there are these update frequencies that you want to take into account. So for mobile app, maybe you don't want this automated. You want this only on a button, like every 2 weeks you want to push a new application, but it should at least be pushable. And with manual testing, you can't achieve that. Manual testing automatically means you have a slow release cycle. With manual testing, you cannot have an agile project. Anyone who says they are agile and they're doing manual testing means they're lying. They're not agile. It doesn't work. How are you reacting to change if you test some manual? It's extremely costly, and it's also extremely slow. And regarding the skill set, I also do not take a developer serious that cannot test. Testing is a crucial development skill. As a developer, if I hand over my code and I don't know whether it's working or not, what type of developer am I? What type of work ethics do I have? When I say my code is done, I should be confident it's working. In other words, as a good developer, I would always want to feel my tester worthless in a good sense. They should never find anything. And also, I mean, in this discussion, typically what I like to bring up, and I bring up here as well, this KPI for testing teams, number of defects found. That's such a bad KPI if you think of it. It means you incentivize one organizational unit for the bad work of another one. That's what it means. It's nonsense. So, for me, testing and development are two things that should have never been separated in the first place. It should always be the same people testing and developing. Now, you could of course argue, but shouldn't there also be an ethics of external scrutiny? For certain products, yes, like a pacemaker, or the control software of satellite, or the software that controls steering of a car. There definitely should be external scrutiny, but these are other mechanisms. Like you go to an institute like TÜV Rheinland and have certification for your process and your testing approach and so on. Then that's another level of scrutiny. And of course, there are software for which the scrutiny has to exist also banking. Not everything in banking, but a lot in banking.
The compliance stuff in banking needs that kind of scrutiny and it's very difficult.
That's what we often think. That's what we are often told by people who think that. Who of us has actually read the requirement specifications about these scrutiny things? So I know two interesting stories about that to tell. CMMI is also, in a sense, a process scrutiny. CMMI is not a process, it's only a maturity model for measuring the maturity of a process. And CMMI was very popular in the late 90s, just like 2 years before extreme programming. And then extreme programming came along, and a lot of these CMMI consultants have run around in circles screaming, how can you do that? Extreme programming is not a proper process, it's violating CMMI, and so on. Which has led the publishers of CMMI, the Carnegie Mellon University professors who have written the CMMI specification, write a paper that shows, if you follow extreme programming, how good you're already at CMMI level 2 and 3 and how well prepared you're for 4 and 5. So sometimes it's just a misunderstanding. Or another situation that I know is product that had to be common criteria EL 5 plus certified. So the highest certification that you can have, I think that's 7, but for 5 plus you have to do quite some stuff. But it works like just checklists. And one of the things that was always claimed is we can't possibly use this or that version control system because you can't tick the boxes there. But it turned out when you dig deeper, that actually all you needed to do is to map the requirements to that other new version control system, and you just might have been the first one doing so on the planet. And that case was about replacing clear case with Git. So quite often we just think that it doesn't work with Agile. It's because we haven't applied the scrutiny. Saying, okay, what are the requirements by that specification for the process, and how can we map it? We just think we can't because we have to change a lot of the existing process. Okay.
Just
Yeah.
one question. Who decides who does
The team. No.
So
In XP, there's no hierarchy. So
then you'll have to deal with favoritism and like that, right?
Well, if you feel like favoritism is a problem in the team, bring it up during a retrospective. Then the team say, okay, you have proof. And then either the team says, yeah, yes, actually, we admit that we have to break it. Yeah. Or the team says, well, yes, but we don't see that's the problem. Yeah, that if only you see it as a problem, the rest of the team doesn't. Yeah, then majority wins in that case. Or the team says, well, we don't believe you, bring the data. Yeah, then you collect the data for you.
Data pull.
Okay. Tests, unit tests are important, acceptance tests are important. They are crucial for the feedback, and test-driven development actually is also coming from XP programming. Test-driven development, the two gurus in our industry about it are Ken Beck, having written test-driven development by example, which has made test-driven development popular, and he also created SUnit for Smalltalk, which was the first proper unit testing framework, and together with Eric Gamma on an airplane flight to a conference, he created JUnit, and that is what gave final kick to unit testing. And the other guru obviously is Robert C. Martin, having given us the freeload test development. Pair negotiation should swap the pairs between stories, also during stories. More rotation means that whatever you do with pair programming has even bigger effects. It is not necessary that the same pair that starts a user story also finishes that user story. And a typical question that sometimes comes from managers about that, but what about accountability? A very simple counter question, but what about trust? And if you don't trust these people, why did you hire them? Yeah, that should not be an excuse for having no scrutiny. Yeah. But for the team, it's either the team wins or the team loses. That's like a football match. It's not like the team lost, like we have two winners in the team. No, the entire team lost. Or the entire team won. Stand-up meeting, I'll not say much about that. You know it from Scrum, I guess. It's just daily exchange, and it's the same thing as in Scrum. Acceptance tests performed by or on behalf of the client to accept the software. By the way, regarding the roles, so in Scrum it's called product owner, and extreme programming have the same role, it's just called differently, it's called on-site customer. But the responsibilities are almost identical to the product owner. In Scrum, you have the Scrum Master, and extreme programming, you have the XP coach. And in extreme programming, the XP coach should be a member of the team who, through whatever process, has gained a certain level of enlightenment about extreme programming that the others of the team do not yet have. The role of the XP coach is to bring the others in the team on that same level of enlightenment. It is not necessarily all others at the same time. You might have a peer in your team who you think is quite capable, they will reach there first. Then you start rotating that role. By the way, the Scrum Master role originally also should have been rotated. Should have been a team member, one from the team, and then should have been rotated. But with all this project manager certification going on, this doesn't happen. It should have been a rotating role. And it should have been a rotating role in the following sense. So you send someone from the team into Scrum course. They come back, now they're Scrum Master. The rest of the team observes, how does the Scrum Master think? How does the Scrum work? When they observe, then they start acting the same things. Scrum Master goes on holiday, you need a deputy. You start rotating it between those two. You start rotating it between more and more people until actually the role should have gradually faded away. A perfect Scrum team does not need a Scrum Master. Everyone is Scrum Master in a perfect Scrum team. The Scrum Master is not a Jira secretary. He's not a ticket pusher. A proper Scrum Master is a change agent, a defender of the process, and an agent of improvement. That's what a proper Scrum Master is. Scrum Master should help improve the process, find bottlenecks. Yeah, you want to say something?
I was about to say that shouldn't the whole team be involved in the meeting and not only one person?
Yeah. Then we have iteration planning. There's like sprint planning, so I'm not gonna tell a lot about that. Release planning depends on your type of software whether or not you need that. Yeah, that's very market specific. And like apps, maybe you want release planning, mobile apps, because you can't push several updates per day. For a backend, maybe you don't need release plan. Then when you have an embedded system, there are actually projects that have natural waterfall elements that cannot be done away with. Like for example, let's say software for a rocket that has to fly to Mars. There are certain aspects about the entire project which you cannot do agile. You can't say, okay, let's fly the first 5% of the distance and then check whether we actually got enough fuel for the mission. And that doesn't work. So there are certain things where agile simply doesn't work, where you have to do a waterfall. You will not see me bashing the waterfall. You will only see me bashing using the waterfall or agile in the wrong place. So we have different feedback dimensions. There's system feedback, team feedback, and customer feedback. Similar to Scrum. Because Scrum doesn't really talk about system feedback. Scrum talks about customer feedback, that's the sprint review. Talks about team feedback, that's the sprint retrospective. But Scrum, it mentions that you test. But if you read the Scrum guide, whenever it mentions test, it feels like it almost had to be forced mentioning that. It doesn't really feel natural reading about testing in the Scrum guide. I wish it were, but it somehow doesn't feel natural. So, practices, planning game, it's just like Scrum. There's no difference. Coding standards. You should have coding standards. You can't do extreme programming without coding standards. How do you do pair programming without coding standards? You don't want to have an argument with every other thing about where to put 30 braces. You have to find your way as a team and then stick to it. And it doesn't mean that you can't have an argument at all about it. Of course, the coding standard is not written in stone. You have to be able to improve the coding standard over time. So, of course, please have arguments about your coding standard, but there still should be an agreed coding standard and a proper process which is, okay, you write it down. It doesn't have to be elaborate. It can be a marked up file in a wiki. And then you improve it over time. And there's a few keywords about what to think in a coding standard. Now, obviously, it's the regularly structured automation principle. What do you automate? How do you automate? My favorite automation tool is Make. No matter which type of project I have, Make is my primary automation tool. It makes sure that my pipeline files are very thin. They only do things like make all, or make test, or make deploy. My pipeline files are very small. And collective code ownership, everyone is allowed to change every piece of code. I'm allowed to change test. Somebody else is allowed to change the production code. Yet another person is allowed to change the deployment script. It's collective code ownership. It's again about avoiding bottlenecks. If you don't know how to change a piece of code, you should be doing it alone anyway. You should be pairing with someone, and if you don't know, you have to pair with someone who knows. But even two fools can be wiser than a single fool. There's another aspect about pair programming which I forgot to mention, it's discipline. People usually behave much more disciplined when they are watched. And it's not only about the behavioral aspect of feeling watched, it's also about the aspect of feeling helped. Sometimes we take shortcuts because we don't know an efficient and effective way to do it properly. And then when we're alone, we're helpless. But if there's someone next to us, even if they might not know, there's already someone we can talk about. Have you heard of rubber duck debugging? Has the following thing happened to you already? You were programming or trying to solve a technical problem and you got stuck. Then what do? There are many things you can do. One of the things you can do is you can talk to a colleague. You walk up to a colleague and talk to them. How often did it happen to you that while you were explaining the problem, you suddenly found the solution yourself? All they did is just sit there and look at you. Just the presence of another human being or the interaction can already help. The term rubber duck programming or debugging comes from when you have a problem. Maybe don't disturb a colleague, first talk to the rubber duck. As an extreme programmer, you don't need to do that, you have your pair. There should be a system metaphor. So when we talk about architecture in extreme programming, it's very different from traditional architecture. We do not design the entire architecture of the entire system up front. The job of software architecture has fundamentally changed with agile methods. We no longer create an architecture for the entire system up front, because that would mean that the requirements don't change, and they do change. I haven't seen a single project in my life that has reasonable lifetime that did not change. By the way, most projects that I know, they also do not run waterfall. Most projects that I know where people claim they're waterfall, they're actually running a spiral model, a small, slow spiral model. But they might go through analysis and design and implementation and test and release, and that might take 2 years. And then they take the same code base and they run another loop of analysis, design, and so forth, all the same code base. So it's already a spiral model, just a very small, slow spiral model. So what we want instead in architecture is we want an architecture that is the best architecture with the knowledge of today for the requirements of today. And what do we do to change the architecture when a new requirement comes along? We refactor. What does refactoring mean? It means changing the structure of source code without changing the behavior. How do we know that we did not accidentally change the behavior? We run the tests. How often should you refactor? Come again, please.
As often as you can. When you get a requirement, you can refactor. You are thinking that a different type of needs different type of way of.
As often as you can.
Normally we refactor when some requirement has come and we know we are not able to fit it into the existing structure.
Exactly, that fits directly here. You can refactor even more often, because when you have a requirement on the superficial level, on the requirements engineering level, you see a new user story and we definitely have to refactor this part of the code. But while you're writing code, you can also find lots of opportunities for refactoring. Deleting a comment, changing a method name, changing a variable name, these are all refactorings. They change the structure of the source code without changing the behavior. You can refactor all the time. In fact, if a team has to plan a refactoring sprint, it means that something has gone wrong before that. At least from the perspective of extreme programming. You should refactor all the time. We're going to come to that quite soon, but that allows us to do emergent design. The reality forces us to do emergent design anyway. But if we try to create an architecture that caters to all eventualities of requirements that may or may not come, we usually create overcomplicated software architectures. Then a very easy cookie cutter that you can do, a coding exercise, the bowling game. It's a very famous test-driven development exercise these days. In the 90s, it has been a very famous OO exercise. And try to find old examples of the bowling game cutter from the 90s and compare that with how the bowling game cutter looks today. It's entirely different and plays so much simpler, which is not a bashing of OO. I think OO is also here to stay. It's just a bashing of wrong OO, and it's a bashing of having no feedback. Tests give you feedback not only about behavior, whether the production code meets the required behavior, but tests also give you feedback about structure. They should not verify structure, because of course you want to be able to change the structure and verify the behavior. But in order to address behavior, there needs to be a surface of structure that tests are interested in. And that surface of structure are the important parts of our design. And that's something where unit tests can give us excellent feedback about. And that's why some people actually already start calling it test-driven design and not just test-driven development. We want a sustainable pace. In the first version of the Extreme Programming book, it was called the 40 hours week. The second version of the Extreme Programming book scrapped 40 hours. I think there were massive protests from readers from France. There were 35 hours a week in France. Why are you increasing my working time? And but the key thing actually is no overtime. For the sustainable pace. Software development is like a track. Actually, in the past, I used a different metaphor. I asked people, what is a software development project? Is it more like a marathon or more like a sprint? But actually, even marathons kill people. So I think it should be more like a track. If you want to, it's also a bit like this. If you want to go fast, go alone. But if you want to go far, go with company. And software development project wants to go far. By the way, there's a fundamental problem with the word project in software development. And the classic project philosophy. Project is something that has a defined start and a defined end. There comes the problem. What is the defined end of a successful software development project? It is non-existent. As long as your project is successful, it does not end. Which is one of the things why there's so much misunderstanding between the culture of project management and the culture of software development. Many of these misunderstandings can be traced down to exactly that point, that those two cultures use an entirely different understanding of the word project. And like on GitHub, how do you call this? Well, you create a repository. It's associated with a project. The project starts when you create a repository. When does it end? Never. Hopefully. Successful projects in software development are successful when they do not end, which is quite the opposite of a traditional project philosophy. Which is also why I think it's so important to think differently of software. A bridge, you can't run a bridge in an agile fashion. There will be agile aspects about how a professional company constructs a bridge. But you're not gonna go, okay, let's change this bridge, and actually you can do that, but it's quite expensive compared to software. Let's change the bridge to have 3 instead of 2 lanes. Now, some bridges it's still relatively cheap, but try to do that with the Golden Gate Bridge. It doesn't work very nicely with a bridge like that. In Pune there are bridges where we do that, but we also do this with some bridges, but with others. We had pair programming, so nothing more left to say that. Proper test-driven development. So what Kent Beck describes as test-driven development in his book. If you're a Kent Beck fan, that may sound a bit blasphemous. It's actually not yet proper test-driven development. It comes close. It's more than just test-first programming. But to me, proper test-driven development is following the 3 laws of test-driven development, which are laid out by Robert C. Martin. You can't write any production code unless you have first written a failing unit test. And by the way, to me, if you write your unit tests in Cucumber, I'm fine. I'm not the person that then argues with you and says, but it's not a unit test framework. I actually think for certain unit tests, Cucumber is the better framework. Especially when your unit that you're testing exposes behavior that is also exposed to the user. Then Cucumber is the best framework because then you can talk with your user over the feature file, which is much easier than talking with your user over a unit test source code. If you haven't seen a feature file yet, ask me after the session, I can show you. Then you can't write more of a unit test than is sufficient to fail, and not compiling is failing. So how much test code can you write? Like maybe half a line, or maybe 2 lines. When you have to go to the production code. But you can't write any more production code than is sufficient to make the currently passing unit test, currently failing unit test pass. That's proper test-driven development. It's laid out the 3 laws of test-driven development by Robert C. Martin. That puts you in a cycle of perpetual ping pong between test and production code. When is the best time to refactor? When your tests are green. Because then you can refactor, run the tests again, and if they're still green, you know you didn't break anything. Which means the complete cycle to which this leads is the, how we do the slide, is the red-green refactor cycle. Then extreme programming says home team. Means something similar as cross-functional team. But also means that, for example, when you do a planning meeting, or you do a retrospective also, or you do important design decisions, that the whole team should come together for that. Which implies that extreme programming doesn't work with large teams. That was intended to. Good team size for extreme programming is like 5, 6, 7 people, maybe 8 or 9. I wouldn't want to go beyond 10, I guess. It would already be too difficult. But I also think that for most projects, we do not need bigger teams. For most projects that I've seen, the teams were far too big. And every new person you add to a team, statistically, I mean, you can talk about the individuals and show exemptions, obviously, but statistically, every person you add to a team is less efficient than the previous persons. Why is that the case? It's actually a mathematical model for that. Let's say you're writing code as a one-person team. With how many people do you have to coordinate? With no other person. You have one node, 0 links. 2 people. 2 nodes, 1 link. 3 people, 3 nodes, 3 links. 4 people, 4 nodes, 6 links. 5 people, 5 nodes, 5 links. 10 links. What's the formula? Yeah. N times n minus 1 divided by 2 goes some formula. So in terms of complexity, the communication complexity of a team has quadratic growth. That is why big teams are much less efficient than small teams. Now let's say your requirements are really so big. What can you do? Use what we call Conway's law. What is Conway's law? It says that a system will inevitably mirror the organization structure that created it. If you don't use Conway's law, it's going to play you. But if you know Conway's law, you can turn it around. You flip it on its head and say, okay, this is the system I want. Like I want a architecture with 3 main components, so I'm going to create 3 teams. That's how you deal with large systems. And it's a wise thing to do anyway. Sooner or later, you will have to break it down. Then the next question is, what if you don't know the borders between the teams in the beginning? Start with a small team, let the 3 systems emerge. Or maybe it's 4 or 2 or 5, you don't know at the start. And then once you know that, then you can break it and create new teams from that. Sit together. Extreme programming is for co-located teams. It can work remotely. It does. I think I've done extreme programming remotely with a 2-people team very successfully for an open source project. We did everything, or almost everything that extreme programming says. Was really great. But I would say this is the unicorn in the soup. It's not the regular case. An informative workspace. I'm glad to be here at Agile Software because you can see what an informative workspace is if you just look at the walls. You see there are screens at the walls which show it's like a health status of a system. That's an informative workspace. You don't need to go onto your desk, open a browser, open a bookmark, and wait until a page is loaded in order to get information. You just, by the presence in the same room as the information, you get the information. That's the key about visual workspaces. Other things that you can visualize besides the health of your deployed system are maybe the health and the result status of your build robots, build monitor, and the Jira board. Also, occasionally I like the definition of done and the definition of ready, and maybe a few changes to coding standards to be cycled through such a radiator board, so that information is shown automatically. Because you can easily get together as a team and decide on coding standard. If you don't write it down, 2 weeks later the coding standard is gone. Then continuous refactoring. I mentioned that before already. Should be able to refactor continuously and mercilessly all the time. And the goal of refactoring obviously is to keep the primary value of software high. Every time we make a change, there is a risk that our change increases the secondary value of software. But it can have a side effect on the other secondary value of software by breaking behavior that we come with tests, and it can have a side effect on the primary value of software. We have a few things with which you can actually measure the code quality. There are metrics for that. We don't have time for this today, but maybe I'm going to give another talk about that. But still, it has to be addressed. It's a much more artistic and creative addressing the primary value of software. There's also a lot to do with aesthetics. And it's actually not that because it's aesthetics, it's subjective. Not necessarily the case. Yeah, there's the goal ratio, for example, a mathematical model for aesthetics. You find it in nature and you find it in beauty. This one, I promised you I'm gonna have another rant about DevOps. So when we created extreme programming, we devised something that we call continuous integration. So what did we mean with continuous integration? Why did we call it continuous integration? Remember there was the 90s. What was the primary language of the 90s? C++. Java was born, but it took until about 2000 until Java really overtook C and C++ as the dominant language. One of the problems in C++ projects and C projects of the time was that people were writing their code, and for integration they exchanged header files, but also source control was not yet in widespread use. I'm very happy that, for example, today and on a day like this, I don't have to stand here and convince anyone of using Git or Subversion. That's eaten, that topic. It's done. We do that. But at that time, people like me were saying that please use source control. And then, okay, what can we buy? Oh, please don't buy something. Just take open source. Second conversation about that. But integration was a problem. What does integration mean? For C programs, you not only have to check that the things compile, but they also link, and that the linked binary actually runs. With Java development is something you don't have to lose your head around about. You do that all the time. You don't think about it. But that was the crucial step that developers missed at the time for making sure that the software can actually be used by the user. So teams were working on their own modules for weeks and months, and then they integrated it, and then integration could take weeks until everything would actually link. That was terrible. And we came up with the word continuous integration, and we wanted to say, do whatever is needed to make sure that the product we're developing can get into the hands of the user. And linking was the need of the hour at that time, so we call it continuous integration. But then the internet came, and Java came. Then we renamed it continuous release. Say, okay, you don't only have to create the artifact, you also have to put the artifact in a place where the user can get it. And then we renamed it to continuous deployment, because then we were on the back end. It's not enough to just put the artifact into your own Nexus, but you have to actually deploy it on the server. The user is not downloading from Nexus. The user is just opening a web page or using a REST endpoint. You have to deploy it. And DevOps is, for me, just yet another rename of two things. It's a rename of cross-functional team. Operations is part of success of the software project. Without operations, the project can't be successful. Operations is the road for making the project successful, so it has to be on the team. It's one of the things that DevOps development operations means. Another thing that it means is we keep renaming things in order to explain what we actually meant. And when I now hear something like we're looking for a DevOps engineer, we expect you to know Kubernetes and Helm charts and Ansible and so on. It's again, you do not get what DevOps actually means. It means not operations, it means development operations. If you're looking for an operations engineer, then please call it operations engineer and not DevOps engineer. A DevOps engineer is by definition of that word, development operations, someone who does both, programming and automation for deployment. If it's only about Kubernetes, it's an ops engineer, not a DevOps engineer. Right over. It seems like we have to keep on renaming stuff because people don't get it. The dev in DevOps stands for development. Automation, very crucial. Can't be successful in software development. But you can, but it's a unicorn. Without automation. You need to automate your build, you need to automate your test, you need to automate your deployment. Automate all the things, whatever you can automate, do. That's actually a good time for spontaneous Google. It's Google for let's see if I can quickly find this. Yeah, that looks good. That's the wrong. No, it's the right one. That's one of my favorite XKCDs. When is automation worth it? It's a nice table. So here is how often do you do the task? Once a year, once a month, once a week, once a day, 5 times a day, 50 times a day. How much time do you shave off? You shave off 1 second, you shave off 5 seconds, 30 seconds, 1 minute, 5 minutes, 30 minutes, 1 hour, 6 hours. How much time can you spend on this until automation is not worthwhile? You see, if you shave off 1 minute on something you do daily, you can spend a whole day on it safely, and it's still worthwhile effort, a worthwhile enterprise doing so. What is not in this picture is the spiral effect. Let's say you have a build system which runs build and maybe also runs a few tests. And your build system takes 30 minutes to run. How often are you going to run the build? Just like 3-4 times a day. You don't have time for more often. Anything you want to code. But if it's taking half an hour and you're doing it 5 times a day, it's already worth spending 6 months on it. Only if you're one person. What this doesn't show you is, what if it's more than one person doing it? So you're a team, 10 people using the build system takes 30 minutes. Then you could reduce, or let's say you can shave off 5 minutes over 30 minutes build. Yeah? Then it's still 4 weeks that you can spend. But if it's 10 people, it's not 4 weeks you can spend, it's 40 weeks you can spend in order to make the team more efficient. Very important thing to think about, efficiency of a team. Make sure that whatever you do often, make it as automated and also as fast as possible. The Git developers, for example, they know that. In which language is the core of Git written? It's in C. Obviously, it's Linus Torvalds. You can code C. And if you're as good as Linus Torvalds, you can say that. Until you're not there, you have to be polyglot like me. But all the things around the core, they originally were written in Python. Until they were feature stabilized, and then they were rewritten in C to make it more efficient. Because they understand, with so many people on the world using a version control system, it better be fast. Has anyone here in this room used IBM Rational Clearcase? Is it fast or slow?
IBM is fast.
Come here, please.
IBM is fast. When we were using it, there were other systems which were much slower. So we were using that in, it was the state of the art at that time.
My opinion, it never was.
Whatever we have used, nameplates like ask what is fast and what is slow. For
Yeah.
me, 1 minute is slow. 50 seconds is also slow.
So I worked on a project where we had about 30,000 files in directories in a IBM Russian team case repository. It actually was IBM Russian team case UCM multi-site. And doing a single file checkout takes almost a second. It takes 1.5 seconds on the system to check in, check out a single file. Check out chicken, yes. Let's check out chicken. And I was typically the person who would do the big changes in code. You know, like we had our own proprietary types, replace them with ISO types. So replace uppercase U in 8 underscore, no, just uppercase U in 8 with lowercase u in 8 underscore t to the entire replace. Just like 2,000 files. How long does it take for Git to process a change set of 2,000 files? It's still like this, it's like 2 seconds. In IBM Russian clear case, you have 2,000 files times 1.5 seconds. That's not fast. And you can say, oh, of course, with a good architecture, you don't have global changes. Still have. We of course try to avoid that with good architectures, but there can always be this new change, this new requirement coming along, this new library, this new logging framework also that requires a global change to all files. And that's very important that we have good tools. So this shows you how much time you can easily spend on automation in order to make yourself efficient and grant yourself and your team that time. It's worthwhile. So that's about automation. That's the end of my talk. Any questions?
If I want to transit to extreme programming or any of the methodologies, where should the change start? Who should take a decision?
That's an excellent question, and it's not an easy question. I don't think that there's a universal answer for that. I think in general, with organizational change, you have to identify the scope of change in 2 ways. Who has to change and who is impacted by the change. And the impact scope is often bigger than the